Good morning students, welcome back to 9th Science, Unit 13, Chemical Bonding Part 4. Now let us recall what we learnt in the previous class. Introduction of chemical bond, Cauchy-Lewis approach to chemical bonds, octet rule, unstable electronic configuration, Lewis dot structure, types of chemical bond, ionic bond, covalent bond, and also Fajans rule. Now you come to the third type of bond, that is coordinate covalent bond. In some compounds, the formation of a covalent bond. Covalent bond is formed between the two atoms. For example, hydrogen and hydrogen. In between both the atoms, they sharing the electrons. So that take place sharing of two electrons, both of which comes from only one of the combining atoms, and this bond is called as coordinate covalent bond. This coordinate covalent bond is also called as dative bond. For example, ammonium ion NH4 plus, then the ammonia NH3, and in between ammonia and boron trifluoride a coordinate covalent bond is formed, and the coordinate covalent bond is represented by an arrow. The atom which provides the electron pair means it contains two electrons, is called as donor atom, while the other atom which accepts the electron pair, it is called as acceptor atom. Here ammonia is the donor atom and boron trifluoride is the acceptor atom. Ammonia is the donor atom and boron trifluoride is the acceptor atom. The coordinate covalent bond is represented by an arrow which points from the donor to the acceptor atom. Formation of coordinate covalent bond. Let us consider the two atoms A and B. The atom A has lone pair of electrons and the atom B, it has only 6 electrons in the outermost shell. So it needs 2 more electrons to complete the octet valence shell. Now atom A donates its lone pair to the atom B, it accepts it. Thus the lone pair of electrons, lone pair means it contains 2 electrons. Here the lone pair of electrons is shared, it belongs to atom A. Now it is shared by both the atoms A and B. Here the shared pair of electrons, the lone pair of electron is sharing from only by the atom A. Here the bond formation by this mutual sharing is called as coordinate covalent bond. So in between the atom A and B, a coordinate covalent bond is formed and it is represented by an arrow. Now come to the illustration of the formation of coordinate covalent bond between ammonia and boron trifluoride molecules. The molecule ammonia NH3, it gives a lone pair of electrons to boron trifluoride BF3, which is electron deficient. Here come to the ammonia. Ammonia means NH3, it contains a lone pair of electrons. Boron trifluoride BF3. Here the ammonia, it donates its lone pair of electrons to boron trifluoride. So this ammonia is called as the donor molecule and the boron trifluoride is the acceptor molecule. Here in between ammonia and boron trifluoride a coordinate covalent bond is formed. So it is represented by an arrow. Here a coordinate covalent bond is formed between NH3 donor molecule and BF3, it is the acceptor molecule, and it is represented by NH3 BF3. In between a coordinate covalent bond is formed and it is represented by an arrow. Now what are the characteristics of coordinate covalent compounds? First one, physical state. These compounds exist as gases. Ammonia is a gas, liquids or solids. Electrical conductivity. Like covalent compounds, this coordinate covalent compounds also, they do not contain a charged particles. Okay, plus and minus ions. So this is they are the coordinate covalent compounds are bad conductor of electricity. Then melting point. These compounds have melting points higher than that of the covalent bonds, but lower than those of the purely ionic compounds. Then solubility. It is insoluble in polar solvents like water, H2O, but they are soluble in non-polar solvents like benzene. Benzene means C6H6. Then CCl4, carbon tetrachloride, and toluene, C6H5CH3. Then the last point, reactions. Coordinate covalent compounds undergo molecular reactions which are very slow. If it is an ionic reaction, it is very fast, but these compounds are coordinate covalent compounds undergo molecular reactions which are slow. The next topic that is called as oxidation. What is oxidation? The chemical reaction which involves the addition of oxygen or removal of hydrogen or loss of electrons is called as oxidation. For example, magnesium combines with oxygen, it forms magnesium oxide. Here the oxygen is added to magnesium. The next one, calcium hydride. It gives calcium and hydrogen. Here the hydrogen is removed from calcium. So this is a removal of hydrogen. The third one, loss of electron, Fe2 plus. Fe2 plus, it loses one electrons to form Fe3 plus. So it is a loss of electrons. So that is called as oxidation. Now come to the reduction. The chemical reaction which involves the addition of hydrogen or removal of oxygen or gain of electrons is called as reduction. For example, sodium combines with hydrogen to form sodium hydride. Addition of hydrogen. Hydrogen is added to sodium. So this is the addition of hydrogen. Then copper oxide. It combines with hydrogen to form copper plus water. This is removal of oxygen. Listen here, and this reaction is also called as redox reaction. So afterwards I will explain, but now you understood. Here copper oxide, here removal of oxygen. Copper oxide to copper is removal of oxygen. Here hydrogen, it addition of hydrogen, it forms water. This reaction is also called as a redox reaction. Here removal of oxygen. Here gain of electrons. Here one electron, here gaining. So Fe3 plus electron, it gives Fe2 plus. It is the gain of electrons and it is called as reduction. The third one, redox reaction. Generally, oxidation and reduction, they occurs in the same reaction simultaneously. Reaction takes place simultaneously. If one reactant gets oxidized and the other reactant gets reduced, these reactions are called as oxidation reduction reaction. These oxidation reduction reactions are also called as redox reactions. PbO, lead oxide, it combines with carbon to form lead Pb plus carbon dioxide. Here PbO is converted into lead Pb. Here removal of oxygen. Here carbon, it added with oxygen, addition with oxygen to carbon dioxide. So addition of oxygen. So a reaction, both oxidation and reduction, there takes place simultaneously. It is called as redox reaction. The second one, zinc. It reacts with copper sulfate to form copper plus zinc sulfate. Here it is a removal of oxygen and the removal of addition of oxygen and the removal of oxygen. So this is called as redox reaction. Now, oxidizing agent and reducing agent. substances which have the ability to oxidize other substances are called as oxidizing agent. For example, H2O2 hydrogen peroxide, MnO4 minus, this is permanganate ion, CrO3 chromium oxide, Cr2O7 dichromate ion. So these are called as oxidizing agent. So these are also called as electron acceptors because they remove the electron from other atoms. Then the substances which have the ability to reduce other substances are called as reducing agent. For example, NaBH4, LiAlH4 and the metals like palladium, PD and also platinum, PT. So these are reducing agents. So these are also called as electron donors because they donate electrons to other substances. Yes, now come to the last topic, that is oxidation reactions in daily life. And some of the examples, the fading of cloths and the burning of wood and the vegetables, fruits that changes its color into brown in color. So these are the some nature reactions that takes place in the presence of oxygen and also some of the oxidizing agents. Here in nature, the oxygen present in atmospheric air oxidizes many things starting from metals to living tissues. For example, the shining surface of metals, for example, aluminum. Aluminum, it combines with oxygen to form aluminum oxide because aluminum tarnishes, it changes its colors due to the formation of an aluminum oxide. For example, silver, it combines with hydrogen sulfide and it changes white color into black in color due to the formation of a silver sulfide. And this iron, it combines with oxygen and also moisture and it forms a rust, Fe2O3 dot XH2O. This is called as rust. So this phenomenon is called as rusting and it is also called as corrosion. The next one, the freshly cut surfaces of vegetables and fruits, it turns into brown in color after some time because of the oxidation of organic compounds. Organic compounds means the compounds containing carbon and hydrogen, it is present in them, it changes its color into brown in color. For example, apple. Apple contains malic acid and also grape contains tartaric acid. So some of the changes, it changes its color because of the oxidation of organic compounds. The next one, oxidation reaction in food materials that were left open for a long period of time is responsible for the spoiling of food. This is called as rancidity. The best example, curd. Here the oxidation of oils and fats present in food results in the formation of a bad smell or taste. This conversion is called as rancidity. So this phenomenon is called as rancidity. The best example, that is curd. Now come to the assignment. What is coordinate covalent bond? The second one, explain the formation of coordinate covalent bond between NH3 and BF3 molecules. The third one, what are the characteristics of coordinate covalent compounds? The fourth one, what is oxidation? Give examples. Okay, these questions you have to learn and write one time. Okay students, thank you.